It's just very intuitive. So you have kind of like points on an XY scale. And what I ask you to do is build me a predictor. So that's some kind of a function that is very close to the original points, but I can use it to predict things that are not part of the original points. So say, if I ask you what is the value of the function at, I don't know, 3, which is not in the original points, you can use that function to estimate it, okay? But here's another thing we could do. We can use that function. It's very close to all the points, but this seems to be a better function at first. Why? Because it passes through all the points. So at least when I ask it, give me the value of a point that I've seen before, it gives you the exact value. Where, as opposed to this one, if I ask it to give me the value of, say, this point, it's going to give it a little bit below, right? So this one seems to be better. But what's wrong with this one? If I ask it to give me the value of a function here, it's going to be all the way in the sky, okay? So if these are cases, let's now situate it back to what we can understand. If these are cases, and these are previous decisions that came out of court, and I ask you to build me a predictor that can look at a new case, say, in between these two cases, very similar to these two, but not quite the same, and ask you, give me a decision. This one is going to give a decision that looks okay, it's kind of in between, and this one is going to be very extreme. It's going to sentence someone to death, okay? So we have to be very careful. Sometimes it's tempting to build our predictors to be very accurate on the examples we saw, and the price is they're useless outside.